Hi, everyone. We will just wait for a couple more minutes before we start. In the meanwhile, I would like to introduce Smitha and Ganesh, who are here from the OpenWeaver team, and to help us with a hands-on session, because we just told them all of you are struggling with the acquiring data, hands-on part, and they will talk about very basic elements. It will not be overwhelming. That is what they promise. And we'll also share the direct link to the assessment. This session and the next session should be the last mile in that to get the certification is what we feel. And hence I'll just pass it on to Smitha without wasting any more time. We'll also wait for a few more people to join before I think we'll go ahead. Thank you. Thank you, Smitha.
Thank you, Anjana. And welcome everybody to the session. Primarily, thank you, Smitha and Anjana and FSP for giving OpenWeaver the opportunity again to work with your cohort and support in the practical aspects of these sessions. So we are really excited and looking forward to today's session. A very quick introduction of who we are and what we do. So I'm Smitha and I work with OpenWeaver as the Director for Community and Partnerships. And OpenWeaver as a company, we are a SaaS technology platform company supporting over 1 million developers worldwide in building their ideas faster by reusing open source software. So our vision is to reinvent digital realization, and very simply put, we'd like to improve the way applications are built. And the way OpenWeaver does this is by using a unique combination of both public domain knowledge as well as artificial intelligence. And this, we believe, is helping deliver smarter ways to build the digital world of tomorrow. So with OpenWeaver, we've been working with FSP for a couple of months now, and we've done a couple of different boot camps at a variety of different levels. And we understand that today's boot camp or today's session is primarily going to be around acquiring data, but more looking into the applications and the practical aspects of the concepts, because we understand you've already gone through the course. You've completed the 10 hours, you've been through the theory and the concepts, and our mentor for today, who is Ganesh, will walk you through how some of these concepts, where their practical applications lie. And then we've also curated some very interesting exercises that you could see Ganesh do, but also participate along with him to kind of get a more hands-on experience of some of these code snippets that work in this area of acquiring data. So with that, I would like to hand it over to Ganesh, who is our mentor for the session, and he is a senior developer with OpenWeaver. So Ganesh, over to you.
Thanks, Smitha. Good evening to everyone. So myself, I'm Lakshmipati Ganesh. So I've been working in OpenWeaver for almost 2 years now as an senior software engineer in the field of artificial intelligence and machine learning. Like Smitha told, I'm aware that you would have already gone through a fair amount of time put together for your theoretical exercises and following up through the course. What we would do today is kind of touch base on majority of the key aspects or key concepts on what the course was about, and let's say merge that with what would be of a real world application or real world scenario in dealing with concepts predominantly like big data, and then let's say choosing what kind of database that you want depending upon what data you get. So based on these aspects, we kind of will go through some real world applications, which we will correlate and see what would be the most apt way of choice moving forward in building a software application, making use of big data. So that is one. And post that, we'll have a hands-on session predominantly on the Pandas data frame. So based on the courseware, those has the predominant hands-on exercises as well. So we thought we'll give a refresher on how to easily cope with that. I hope it isn't overwhelming. Let's see. And yeah, let me go ahead and share my screen. All right. Okay, to start with, we'll have this session outline for the day, which is basically we'll discuss the big data and its life cycle and the choice of frameworks which we could use for the big data. Then we'll go ahead with types of different data, and then the choice of databases which we could use. Both of these will I'll give some examples on both of these topics, which could be applied in real time, and then we'll go ahead with the hands-on exercises, and then followed by a QA session. So yeah, to start with, you would be already aware of what big data is and why do we call it a big data, and what's the difference between a big data and a small data, as in like in the size wise or the volume wise or variety wise, whatever it is. So when we just follow a big data lifecycle, it involves 4 different main processes, which is basically acquiring data, which you really need it. And then if you want to build a software application, you want to store it somewhere. And then once you store it, you have to do something with the data, right? So let's say you do some analysis on top of that. And after you do some analysis, either you store the results or you display it to the user or the company by creating reports. So that is involves the visualization of that. So these are the 4 key aspects of it. And let's say that we could see how big data is used in real life and where it is actually being used. So predominantly it involves majority of the big data is in all these domains, predominantly in banking, because we do enormous amount of bank transactions and there is a huge user base. And then comes the e-commerce, which is basically like we have products online which are being shipped and shopped, which we use on a regular daily basis. And then goes ahead like healthcare, and then media. Media is where you have all the streaming platforms, Netflix, Amazon Prime, or whatever. So all these, and then some education platforms like EduCBA, Coursera, MOOCs, whatsoever it is. So, and the telecom. So these are like different domains of where big data could be used. And now comes the question that how could I choose a particular aspect of big data? Let's say if it is going to be big data, that means that I have to tackle 3-4 different problems. One is like the data that is going to come in will be huge and it will be of different varieties. And it will also be in very bulk quantities. And I'll have to also tackle, let's say, if it is going to be real-time data, as in like transaction data. If we do a transaction in a bank, it has to immediately be reflected on the database for flagging or other purposes, if it's going to be any anomaly transaction. So these are the key aspects that needs to be taken care of. So first, we'll just consider that let's say if I'm going to build a banking solution, I'll have to first decide if the data is going to be bulk or incremental, which is basically like if the data I'm going to is going to be one-time load. They'll give a full TBs of data from a hard drive. I'll just load it in my storage and then put it in a storage. If that is going to be the case, or is it going to be incremental, as in like daily, I'll have to keep loading whatever data that comes in, or every hour I'll have to load it. So this is the key differences which identifies which version or which type of data processing pipeline should be used. Then comes the data storage. Once I decide what kind of data input I'm going to have, what type of data input I'm going to have, I'll make use of certain applications or softwares which will process process the data in this manner. If it is going to be bulk, I can use something of a big like a Hadoop, and if it is going to be incremental, I can use something of frameworks like Apache Storm or Kafka. Then next, then you have the data, then you'll have to store it somewhere, right? So there comes like there are different types of storages which you could use. Like there are files, blocks, and objects. And the key aspects or key differentiations between these 3 is the nature of how you will use the data after being stored. Each has its own characteristics. Once you store it in a file, you can read it so many times. And if it is going to be blocks, you can store it in bulks with limited amount of cost. So all this storage big data typically happens in like cloud predominantly, because it is very big and it takes a vast amount of infrastructure to hold it in one particular physical place. So typically majority of the big data work happens to the cloud. So you have you could actually create a database in the cloud, put all this data in a particular database and store it in any format that you want. If it is going to be files, if it is going to be objects, anything you want, based on what you are going to use the data for and how you are going to use the data with. So these are the two aspects you'll really consider there. And then you have the data, then comes data processing. Okay, so I am going to read the data and then I'm going to do something with it. How soon I am going to read the data, and is it going to be like once a month or once a day? I read a chunk of data, do some analysis on top of it, and then throw it out somewhere else. That is one aspect. That is the batch processing. The real time is one where I have, let's say, a sensor data, a weather data which comes in every minute. So you keep getting the updates from the weather station, and then you process it and tell the users, telling that, oh, okay, there is going to be it's going to be raining in the next 1 hour. So these are something very unpredictable that comes in real time, right? So this data has to be processed in real time to be given out valuable information to the users. So all the frameworks or software applications which serve the purpose of solving this entire use case, we'll have to choose the frameworks depending upon this. So this is a theoretical part. And then we'll go ahead with types of data, which is basically you would be aware of unstructured, structured, and semi-structured. So structured data is typically, let's say you go with tabular data, which is highly organized in the sense you have a user database in your bank that says that there is a bank branch, which lists there are numerous users, let's say 100 users in that branch. It will have a database that states, okay, you will have the account ID, account information, account name, and whatsoever account created date, all those information in a tabular format. This will be stored in a database. So this is called a structured data, where people could actually filter and see, similar to an Excel sheet. And then you have something called an unstructured data, which is kind of vast data that is available online, which is basically all articles, blog posts, text data, or images on the internet, which you actually read it and then do something out of it. You analyze some blog post and then say that this blog post lists something like that, and you want to do some natural language processing on top of that. So this is unstructured data. Semi-structured data is something that involves, let's say, both structured and unstructured, in a manner that if there is an image, the image is going to be an unstructured data, because it you cannot save it in a tabular format. But then what you could do in a tabular format is you could say that what is the size of the image, what is the aspect ratio of the image, what is the resolution of the image. So these are metadata which are attached to that particular image and could be clubbed with and stored with. So these are semi-structured data. These are 3 different formats of the data. Then we go ahead into finding what choice of database are useful for what applications in real time. When it comes to databases, like we typically know, there are only basically 5 concepts or key aspects which needs to be considered. First thing is the concept of nature of data to be stored. Nature is where, if it is going to be stored in a database which will not undergo multiple changes, or the second thing is if it will be a not defined data, not a tabular data, it will have different way of new columns being added. So these are 2 different points there. And the third comes the scalability. Scalability is primarily what you called as expansion. There is vertical scalability and then horizontal scalability. Vertical scalability is when you say the data keeps added in one particular machine alone. You keep on adding more tables. But then if it is a horizontal scalability, you can say that if numerous users come in one at one time, you have a banking software, a banking website that you have deployed on the web. Numerous users ultimately sign in to that bank interface at one particular point of time. Then it has to withstand and cater all the users at that particular time without undergoing any downtime. So that means that it has to be scalable horizontally as well. So that is the second point. And then goes queries. Queries is how often you do some analysis on top of the database and then get some result out of it. And let's park it there. We'll go to the two main databases that is actually present there, which is basically something called as a SQL database and something called as a NoSQL database. To provide an example of a SQL database, predominantly all of the banking softwares which have tabular or fixed schema. There is going to be, if it is going to be a transaction data, it is going to involve only so and so columns, nothing more than that. If it is going to have any more changes, they'll create another additional column like an Excel sheet and then recreate the entire database. So it will have a fixed schema. So that is why it is part of a SQL database. And when it comes to NoSQL database, we can have something, an example to be like all media houses, let's say Netflix, Amazon Prime, or even the e-commerce sites. So they have a flexible schema, which is basically like it will have user data, and then it will have all streaming components which are specific to that user data. Let's say all recent shows watched, all recent show released. So these are different components that are present in their servers, which will reach us. This has to be saved. If I'm a user, I log in into my Netflix ID. I see so many thumbnails which is pointing at me, telling that, oh, you have to watch this, you have to watch this, you have to watch this. And that keeps constantly changing. And it has to have a flexible schema. So for me, if I watch one today and if I watch another tomorrow, it keeps changing. And the duration at which I watch, many different parameters are being captured and being stored in the database. So for those aspects, it has to go through something called as a NoSQL database. It has to be still saved there. For whatever there is a specific structure, you put it in a SQL database. For whatever it doesn't have to be in a specific structure, it is bound to be always changing. You could always put it in a NoSQL database. So these are the two main aspects of how to choose the database of choice. And then to provide more example on the same, there are many different types of SQL databases as well. Each has its own capabilities or characteristics or functionalities. All the banking, all the e-commerce sites predominantly use structured data. And these structured data always go inside databases. That is because they have to make use of these databases or the tables that you typically call it inside a database, in a SQL database, right? In a table, you'll have to generate reports constantly. So you'll have to query it constantly. So whenever there is a query part being involved, you'll have to keep querying it constantly. Then you'll have to store it in a fixed storage, fixed defined structure storage. That's where a SQL database come in. The NoSQL databases, on the other hand, let's say if it is going to be a Google search engine, then it's like it has a vast, it encapsulates a vast thing that is available in the web. If I want to search something on the Google, it already has to have a database at the back end, right? To understand my query and then fetch whatever details I want by scanning through all its databases. So, and it cannot have a fixed database because it is not bound to. The entire world is so different and it can have any amount of data and any different varieties of data. So it cannot basically encapsulate everything in a specific tabular structure. So that is when they make use of something called as a NoSQL database. I hope you guys are clear as far with regards to where we actually apply the SQL databases and where we apply the NoSQL databases, and when to use the structured data and when to use unstructured data. Okay, so then after all this, we'll go into the concept of something called as the Pandas data frame. Hope you guys are already aware of what Pandas is. Pandas is a
Ganesh, just a quick thing. I'm trying to understand if it may be better for us to break here as the first part and get some questions before you
that
go
would be a
into
better
the next
idea.
part.
Sure.
Smitha, Anjana, should we do that maybe?
Yeah, we can do it, though there are no Q&As, I think, because Ganesh has explained it so well. I feel that
So we can ask anyway.
we can ask if somebody has any queries so far before we move forward.
Because I believe the next section of what he's going to talk will include some practical exercises. I'll give a link where everybody can also go there and do the exact same thing that Ganesh will be doing. But maybe we can, if anybody has any questions, please put it on the chat. Or if you want to unmute and speak, if that's possible, you could do that as well. So we'll wait for a minute.
Okay, there is one question. What about in case data needs archival?
Okay, so in case of data needing archival is a different concept totally, because the archival concept comes into place when you don't actually need the data to be active. That is, you need the data, but you don't have to, let's say, do any query on top of it. You can put it in an archive. So this archive is available both in SQL and NoSQL databases. So predominantly it is available in NoSQL databases because it has a huge variety of data, and you don't actually constantly need all the varieties of data. You only need specific components of that data, which you will frequently use. For whatever that is not, whatever we are not using it frequently, we could put it in an archive. It is both available in SQL and NoSQL.
Any other questions? Anybody has questions? When we say SQL is fixed schema, what does schema means? A process?
Okay, yeah. Schema isn't a process. Schema is an outline. Let's say you have an Excel sheet, okay, and it has 3 columns, which with column headers, and let's say 10 rows. So it will have 3 columns, 10 rows, and the schema would actually, what the schema actually means is that schema tells that, oh, this is the column name and these are the contents, the column name and the contents, column name and the contents. So for what data you have, the outline or the structure of the data is called as a schema. And the schema will also include, let's say if it's going to be a column database, then there is a column header, and you will have all data for that particular column underneath it. It will also involve the information of what data type of that particular column is. So that is what you call as a schema. If it is a column, then the column data type and the data inside it. That is a schema.
Anybody, any more questions so far? See, the reason we are doing this part is that, so the reason we are doing this, yeah, can we get this PPT? Oh, sorry, you're saying question and answer.
There is a question actually, which says, in case unstructured data is linked to structured one, which one to use?
Vipul, can you a bit be more elaborative on this? I didn't actually get the question, sorry.
Okay, I think there is another one which says, could you please elaborate on metadata?
Okay, so metadata, like I said, okay, you have an image. Okay, I have your own image, a passport image, whatever. You put it in your computer, you have it stored in your computer hard drive. When you click on properties, right, you will have all the details of that particular image. Let's say, what is the size of the image and what is the aspect ratio of it, what resolution of the image it is in, and if it is in what kind of file type it is in. It is going to be PNG or JPG. So these are all a metadata, and a dictionary is not exactly the same. A metadata is it involves aspects of that particular data point, let's say an image, but a data dictionary is kind of like it involves an overview of a group of data points. That's what you call as a data dictionary usually. If it is going to be only one, it is going to be a metadata. They are similar in aspects, but the way you apply it in a concept is a bit different.
I think we have one more from Abhay Singh. Is metadata and data dictionary the same?
I just answered that, Smitha.
Okay, cool. I think that's about it. Maybe we can move forward, and if something else comes, Ganesh, you can take it from the Q&A section when you break for another round of Q&A at the end.
Okay, sure. And
I think Vipul has explained what he meant. He meant that you said that for unstructured data to use NoSQL database, and for structured it is SQL database. But what if both the data are together? You know.
Okay, if both the data are together, then
yeah.
what typically is done in an industry standard is they'll make use of both databases. It's not that you'll have to use one. You can combine a NoSQL database and a SQL database as well. But then all those are structured will go into a SQL database. All those are unstructured will get stored in a NoSQL database, and you will have a common place where you can connect these two databases and get the data simultaneously from both. You can both use that simultaneously in a application setup. It's not like either this or that. You can combine and use it. Only that for which aspect of data you need to use a SQL database, and for which aspect of the data you need to use a NoSQL database is up to us. We could combine and use it. So
yeah, Malini has a question. What is a database structure?
Okay, so a database structure typically, let's say, okay, you have a database is where you have an entire collection of all your data points, and inside database, if it is going to be SQL, you have something called as a table, and inside table you'll create multiple tables, and inside table, the structure by default of a table is the row and column. That is kind of an Excel sheet. That is what is termed as a structure, and all the column names and their data types is what called as a schema or a structure in a SQL database. If you come to a NoSQL database, the concept is still the same, but it is not something fixed. Let's say for you call it as collection. Okay. There are different varieties of NoSQL databases. I think it will be a bit complex. There are different varieties of NoSQL databases. For example, let's say you don't have a defined structure. You have one user giving 3 column fields and another user giving some 10 column fields. You cannot define a structure telling that there is 10 column fields, right? So it's going to be different. So the entire schema is what actually defined as the structure, and schema, structure, outline, these are all the same. And can we convert a NoSQL DB to SQL DB and vice versa? Actually, we cannot convert a NoSQL DB to a SQL DB. There is a purpose why a specific amount of data is being stored in SQL and specific amount of data is stored in NoSQL. And even if we do try to convert a part of it, applying to their characteristics, there will be a loss in the optimal use of that particular database. It is being served for a purpose. So better that we adhere and understand the characteristics of these databases and store the data accordingly. Okay, if SQL, we can use Oracle or SQL Server. Yes, that's true. Or Microsoft MS SQL Server as well. That's true. And then what about NoSQL database? So there are different, even in NoSQL databases, right? So there are like 4 different types or varieties of data. And for each of the varieties of the data, you have different databases. So for examples, I could give is MongoDB or Cassandra DB, or Redis DB. So there are different databases as such. How to choose database like MySQL or Oracle DB or MongoDB? Okay. Choosing the database in it is, I guess you'll have to work with data more. Once you see that anything tabular that goes into something of an Oracle DB or a MySQL DB, then you don't have anything of a tabular structure. You have like a key value pair, as in like a JSON data, which keeps constantly changing. The dimensions keeps changing. So in that case, you would opt for a NoSQL database. And even like I say, even in NoSQL, there are different ways or different parameters which you have to decide to choose an optimal NoSQL database as well. I think it comes with sufficient amount of experience in working with data. That's when you could actually decide it. The commands are basically, if I think what you're asking is the queries, that is not exactly the same. With a SQL, it's like a predefined select blah blah blah, whatever it is, joins and whatsoever. But with NoSQL, we do have the concepts the same, but the commands are not the same. Even in NoSQL, you could do joins between 2 different databases, but then you cannot do active queries like entirely using the same query. since the process is entirely different and the concept is entirely different, the way you approach or extract or do some operation with the data is different. But the concepts are there. There are more similar concepts.
So Ganesh will move forward.
Sure, yeah. 1 minute, let me just take.
Not a
water.
problem, yeah.
Okay. Thank you. We'll just go forward to the next section then. Okay. So the next, what we are going to see is basically something called as a Pandas data frame. In your courses, you would have already been aware of what a data frame is and what is Pandas. To reiterate on that, a data frame is basically kind of a tabular data structure, which has rows, columns, and data in it. The entire data is defined only in a tabular format, and you could do multiple operations inside it. Basically, we'll do some of that. We'll touch base on a few. This is a initial session, so we thought we'll just use few of the steps in the entire data analysis pipeline without pushing too much on the technical side. Yes, we'll go on to the hands-on session. I think before that, Smitha, if you could share the link in the chat.
Yes. So just an FYI for everybody here, what we have done is, because there are multiple exercises that we are going to do, we didn't want to keep putting it on the chat every now and then because it may get lost between the other chat messages. So I am sending a link here on the chat right now, which is a page on our community, which has all the exercises on it. So if you could also open this page, and Ganesh will simultaneously open it so you know what it looks like. Just click on that community link page, and that will lead you to the practical applications, which has all the other links inside it.
Yes, and thanks, Smitha. So we'll be focusing on, let's say we have created some 6 exercises, and these are simple ones, but you could always pause me and then ask questions on the same. There are 3 main processes involved in the data analysis pipeline, which is input-output operations. You'll have to read the data, and then once you read the data, obviously you have to write it somewhere, right? So you have to write it back. So the read and write operations. Then comes the basic manipulations. So basic manipulations include, let's say you have a data and then you find some summary statistic basically out of it, and some little bit another level one is basically a sorting a data frame. So we have limited time, so we just accommodated only 2-3 processes or modules here. And then after, let's say we have some data manipulations, there is also an interesting feature in Pandas. Not many people would know it, but still, even Pandas data frame could be visualized without using any external library as well. These all involve very simple commands. So we have kind of curated a collection which you have in the chat. Each link has specific collection for that particular process. Let me go ahead and view it as well. 1 minute. Okay, so here is the page, and the prerequisites for this involves only 3 things. You need Python, and if you do not have, and if you wish to continue alongside, you could install Python through this link as well. And you'll have a Jupyter. You need to have a Jupyter notebook. If you don't have one, you could install this through this command. Once you install the Python, you just have to run this pip install Jupyter in your command line, and it will install the Jupyter notebook. Then once you install a Jupyter notebook, you also need Pandas, because that is what we are going to work with. And you'll have to just run this pip install Pandas command to have Pandas as well. And as for me, I do already have the setup of Python, Jupyter, and Pandas. So what I'll do is I'll skip to the next part where we have 6 concepts here. The first concept we are going to tackle is reading data from website, which is basically through a Pandas data frame. So, oops, sorry. So Yeah. If you go ahead and see it, let's say, this page is something we curated in Candy for the users, basically to understand that we have a code snippet, which we have in the code section. What users have to do is just copy it and paste it in their Jupyter notebook, in the cell of a Jupyter notebook, and run it. And then there is a reference image also telling that if you run this particular command, you will see this particular output. So that way we kind of correlate better, easier for the users as well. So the instruction states clearly that all I need to do is I'll have to copy this, put it in a Jupyter notebook. For that, first I'll have to start the Jupyter notebook. I could start the Jupyter notebook by typing in Jupyter notebook. Yeah. So when I type Jupyter notebook, it opens a Jupyter notebook for me, and then I'll create a new notebook, and kind of 1 minute, kind of name it as Pandas exercise. Okay. And the first concept which we just saw is reading data from URL. So there are different ways you could actually read the data. The data can be in your storage. You could have a CSV file in your computer and then read it, or you could have the data in any part of the website and then read it as well. In this, we are just going to make use of the website data. All I have to do is I'll just click on copy here, and then the code gets copied. I go to my development environment, which is basically a Jupyter notebook, click on the cell, and then paste it. All right. And then I'll have to run it. So I can click on run, or I can click on shift enter or control enter. See. Oh. What am I there? One second. Okay, 1 minute.
So Ganesh, some people may not have admin rights, supposedly, if they're doing it on a system that is of office or something. So could you also share some cloud environment where they can do the Python coding of, of Jupyter Notes without installation?
Yeah, sure. Always, there is a possibility that they could use something of Google Colab, that is an open source one that is free to use. All you need is a Google account for it. And then they could actually create a Google account, copy it, and then run it as well. Can I share the link of that here?
Yeah, sure. On the chat. It would be great.
Yeah, 1 minute. Google Colab.
So Alok, you don't have to copy, you have to click on the link. It will work. Ashish has a question. Will it work on Thorny?
Okay. Will this solution work on Thorny?
Yeah, I think he means Jupyter notebooks. I'm not sure. Ashish, do you mean Jupyter?
Yeah, it would work. It would work. Thorny is basically an IDE like Spider or PyCharm. So it will work. It's just that you won't be able to see the result instantly. With Jupyter Notebook, you click on it. For every cell, you will have an output. but it won't be the case for
Are you sharing your screen is what he's asking.
yes, I'm sharing my screen.
We are
One
seeing
second.
command prompt only.
Oh, okay. One
Yeah.
minute.
I thought you were doing something there, so that's why it's up.
1 second.
Okay, so there is a question from Uma also, how to open Jupyter Notebook. So Uma, we have shared the Candy Kit link of OpenViewer here, and where you can go and it will directly show you how to install Jupyter Notebook. And then once it is installed, then it will, you can click on it, it will be downloaded and you can open it from there, or you can search, it will still be visible to you as Jupyter Notebook. And it is there. Smitha has pasted it. I'm going to paste it again in the question and answer link for you.
Yeah,
In
I
fact,
just did.
Yeah, okay.
Yeah. Okay. So the reason I got this error is because I recently updated this. I recently updated this Jupyter Notebook. So this is an internal dependency, PyTZ. So this PyTZ module hasn't been installed when we installed Jupyter. So yeah, we just installed it. Let's see if it works again.
Maybe you can go from the beginning again, Ganesh, so that people can follow through.
Yeah, sure. Is there any way I can minimize this particular small tab here? Anyone knows something? Because I'm not able to see what is underneath the command prompt.
We
Okay,
see only the
restore it.
command prompt.
Yeah, okay. All right. You're able to see the notebook now?
Yeah, it's opening, I think. Yeah, now we can see it.
Okay. So earlier we had this issue because there was an internal dependency that hasn't been met, and it was a PyTZ. Whenever you come across some no module named something like that, you can just install it by typing pip install that particular component.
Could you zoom the page? Is it possible to zoom this particular page of Jupyter Notebook?
Is
Yeah.
it fine?
Yeah. I think it would be better for
Yeah.
people to understand.
So whenever there isn't an package that gets installed, you could actually install it manually, like how we install pip install Jupyter. You could install pip install PyTZ. That's what I just did, and then you'll just have to start the session over again. So I started a new notebook after installing it, and then I copy pasted the code. Now that the read underscore CSV is a function which predominantly encapsulates reading all CSV files, be it from whatever data sources it may be, online, offline. You just, if it is going to be near computer, you'll just have to give the accurate absolute path of that file where it is present in. Now, just to see what the data frame actually means, what is inside that, you'll just have to type df, which is basically the data frame where it is being stored, and it will give you the details of what the data is. So this is a sample mock data which we obtained from the internet. This has some date values and some ticker values of particular stock as well. So this is the first part. This is where you read the data. And this reading, like I said, reading could be in two phases. One is through the local data, or anywhere on the cloud, anywhere on the internet. You just have to get the link, paste it here, and then call this Pandas read CSV function, and it'll work. So this is the first part which we just saw, and then which is basically read data from the web. And then we could go ahead into when you do a read, you obviously have to write it somewhere, right? Then we have something called as a write Pandas data frame to CSV or Excel. When you click on it, you still have the code here, how to save a Pandas data frame to an Excel file, and you'll have the code snippets for it. What I'll do is I'll copy here, and if I paste it in one cell, the problem with Jupyter Notebook is it will run both the cells, but it will not display whatever the output in the first cell. So we can go ahead for our interpretability I'll put it in 2 different cells. So the first cell, what it will do is it will convert this particular data frame into a CSV file. And I named this CSV file as output.csv. And the index is false is something, a parameter which says that if we give it as true, it will generate another column telling that, 0, 1, 2, 3, for whatever rows we have, it will create this. So this is basically the index 0, 1, 2, 3, 4. This is all called as an index. And if it is set to true, it will create another column for it. If it is set to false, it will not get it. What we just needed only the data, not the index. So we can just run it. And to verify that, this particular file is in documents and then data analysis. And yeah, we just worked on the Pandas exercise notebook, and this output.csv is something that's been created here.
So did you give the location, Ganesh, or did it automatically pick this location for you?
If we don't give a location, it generates it on the current location. If we want in a custom location, we could give the entire absolute path. Let's say if we want it in downloads, then I can say C user, my username, and then download, and then the file name.
Basically, you have to define the path where you want the output to be stored.
Exactly. If you want it in the current directory, you don't have to give any path. It could be just the file name, and it will create it in the current path.
Current, wherever Jupyter Notebooks is stored.
Wherever Jupyter Notebook has started. Yeah, wherever Jupyter Notebook is stored. Exactly. Both are the same.
Okay. So for everybody who is downloading Jupyter Notebooks, I think it will be by default in your C downloads. And then maybe you will also see your CSV there. For in case of Ganesh, since he works on it very frequently, he has a storage location, which is different. So I'm assuming you don't have to put a path. If you will still see it there.
Yes. Let's say you could simply use any folder that you want. If it is going to be in your downloads folder, you could create, you migrate to the Jupyter download folder in your command prompt. Let's say if you want your Jupyter Notebook to open your download, then you could say CD, then your downloads folder path. Then
Ganesh, your command prompt is coming up.
I just opened it to show.
Okay, sorry. Okay, so some people have, some questions have come up. Okay, could you write in the command in the Jupyter Notebooks if you want to give a path? For example, in your case, supposedly you want the output in the downloads. How would you define? Where will you write the path? Is what?
Okay, so let's say I go to my file explorer and click on downloads, right? And this is where. Okay, inside anywhere, I want it here. Okay, so I copy it, select and copy it. This will be my entire path, users, Lakshmi Ganesh, downloads, and whatever folder you want in. And then go to the Jupyter Notebook. In this place, you copy and paste it. You paste it. And one thing to remember with Windows and Jupyter Notebook is you'll have to put your slashes in the front. It should not have backslashes because it will usually skip it. The Python is usually designed to skip this backslashes. You'll have to edit the slashes alone here, the path of the slashes. And then I've kept it as output.csv itself. You could name whatever you want to do and then run it. Now, if we go back and see at this particular folder, this output.csv has been generated.
Ganesh, there's one more question of how do you do the same thing in a Google Colab?
Okay, with Colab, it's a bit different because it doesn't have a hard drive attached to it. It is in totally in cache. So with Colab, let's say you open a notebook and then you copy paste this and run it. It will still generate it in your runtime. You do not have to give any folder name. You could just give the file name alone. It'll at what directory your Jupyter Notebook is in the same directory, it will generate the file, the output file. But it will be present only for that particular runtime. Like you cannot actually view it. Let's say you have a network disconnection, then you cannot actually view it. For that, you will have to attach your Google Drive to your Colab notebook so that it has a permanent memory. It's like how you attach a hard drive to your computer. Like RAM and ROM, right? So if and whatever happens in RAM that gets over once the session is over. With a ROM, it kind of acts as a permanent storage. The same concept applies to collabs. If you want it to be permanent, you have to attach your Google Drive. If you don't want it to be permanent, you want the result to be stored only for that session time, you could just simply type the file name alone and it will work.
So we have Amrendra who is writing that he has a error. Data 44 is equal to, he's written the whole thing also. But I've used it in Jupyter, but I'm not getting the data frame.
Yeah. What is the error you are getting, Amrendra? So there is one common error which we might get in getting data from URL, because these websites will have specific timeout limitations. Okay, so what will happen is, based on your network characteristics and your operating system restrictions whatsoever, when you send a request to that particular website, which is basically that HTML which you just said, it will read it, but then if it is going to be a time-consuming one, it will wait for some time, let's say 5 seconds or 10 seconds to get a response from the website. If it doesn't get a response, it will give you an HTTP error telling that your connection has been timed out. So there are settings which you could use to actually increase your session time, timeout session, and then repeat the same step.
Govind, we have shared all the links on the WhatsApp. Okay, so Amarendra want to know if you can read one URL from website and show us over here.
Okay, so what we just saw is from a website. The entire it's through a website. We just saw it and then read it. It's through a website. Or you want me to do something different? Okay, we'll read another one as well. Probably we have another data set which we'll use that will read it from the website. Probably in the next exercise, maybe. Yes, if there's nothing else.
So
Yeah.
quick thing, Ganesh, Smitha and Anjana, question more for you. We have 6 exercises and we don't want to rush it. And I also know we have a session on the 2nd. What would you recommend we do? Would you like to?
So hands-on was something we wanted to take slowly, everyone. So and also we are just left with 5 minutes. So we will do continuation of whatever we did today in the next session, which is scheduled on 2nd.
Got it. So maybe what we could do then, Ganesh, is you can review these two once again, and let's open it up for questions. So maybe slowly do the first 2 exercises and let's take questions, and then let's keep exercise 3, 4, 5, 6 for 30th, for 2nd.
Okay, yeah, makes sense.
Because I don't think we should rush this. This is the more significant part.
That's true.
Yeah.
Also, I request everybody to, in the meanwhile, be absolutely having the Jupyter notes installed, so that next time we meet, we don't go through that part, you know, that, oh, I don't have Jupyter note, because then you won't be able to practice it. So that is, and some people are asking for links. So I've put the WhatsApp group, come over here. We are going to share everything over here again. Also the session recording we will share. While we will share Zoom now, later on it will be uploaded on YouTube, so we can share that link later. So in the last, we had, actually this session was supposed to be 30 minutes from OpenViewer, but because of questions and all, it just got extended, and I had kept a 1 hour session. So do you guys have any questions related to whatever has been done so far? Very, very basic questions to get started, so that next session, everyone comes prepared, and, you know, those areas will be not touched upon, and we will move forward from here.
Correct. So I think, Ganesh, maybe what we could do is focus on helping them download Jupyter and keep it for the next session. And once they have that ready, I think we can move forward with all the 5 exercises. It will take maybe at the most 30 minutes. So we could keep that as a this page, the link that we shared with you over here, that page is going to be open. So please go ahead, download Pandas, download Python, and download your Jupyter notebook and keep it ready. If you would like to check out the exercises on your own, feel free to, but we will be doing an in-depth demo again on 2nd, and then you can follow with us because you would have had the Jupyter notebook open already. Also, I think, Anjana, there's a request saying if they can share screen so they can show us their errors.
Yeah, we can maybe do it next time, Amrendra. I saw your thing. Today we were more focused on first theory part of it. And towards the end, we did Jupyter Notebook installation and kind of running. In fact, OpenWeaver has a dedicated place only for this course, if you look at it. So we wanted to cover this part. Next session, when we have hands-on, maybe we will have that option in the Q&A, wherein some people can share and, show us, and we can get that part resolved. So today, this was only last 15 minutes that we had a little bit of discussing. So yeah.
And also we in the community link, which you will see all the list of the courses. We have a forum there underneath. People could who have some issues or any errors, they could just post it in the forum as well if needed, and we could address that. Sounds good, Smitha?
Yeah, I think that'll be great. So if you have any problem in installing Jupyter and things of that sort, just to be prepared for Friday, you could use that community platform, click on reply or a chat. You need to be signed up for that. And then you can reach out to us and we will get back like anytime during the work hours. We will help you install it and keep it ready. So that on Friday, you can open it along with Ganesh and you can do exactly what Ganesh is doing and follow through. And then if you have errors, we can support you as and when you come across any errors. So that page that Ganesh, you can just open that community page and just putting the link again for everybody here. That page is this. And then if you scroll down, you'll see a reply button. But when you click on reply, it'll ask you to sign in. So please sign in or sign up. And then you can just share a screenshot and we will get back in touch with you. You can also see a private chat function if you log in, where you can just message only us, and that way the others will not be able to see it if you want to do that. But both private chat as well as a forum thread kind of a chat is available for you to troubleshoot, for us to troubleshoot.
Right.
Okay, with that, we will pause for today. Anjana, over to you again.
Thank you, Smitha. Thank you, Ganesh. I think people are very overwhelmed with this itself. So I think good that we broke it into two parts. And I see a lot of people having a lot of queries related to Jupyter Notebook. So like Smitha said, in fact, we would like you to give 1 or 2 days. In these days, you should have had Jupyter Notebook installed. Maybe try whatever is here as an exercise, and so that next time when you come, you have those queries handy to get them resolved. We want you to be ready to take the certification, because that is this whole exercise is to support on that front. Smitha, you want to say something?
No, so the request to all of you who are there here today is to go ahead and purchase the assessment. That puts the back pressure on you, right? That's the only way you'll clear it. We want all of you to clear it before this year ends, so that you start the new year with the one extra certification in your kitty. Thank you so much. Thank you, Ganesh and Smitha.
Thank you, Smitha. Thank you, OpenWeaver. I must thank you. I didn't actually expect you would have had everything of acquiring data set up. So I was asking him for a little bit, but thank you for having that there.
Thank you.
Thank you, Smitha. Thank you, Anjana, and thank you, everybody.
Thank you, guys. Thank you so much, and please practice. Happy learning. Bye-bye.
Thank you.
Bye.